So for solving a quadratic inequality, we start off just like solving a quadratic equation, where we want to make one side equal to 0. So I'm going to do some preliminary work here. I'm going to distribute the 3 to get rid of the brackets. And that negative 3 times the negative 1 will be a plus 3. And then I need to make one side equal to 0. Now, for me personally, I always like, for factoring purposes, to keep the number in front of my x squared as positive. I find that's easier to factor. So in this case, I would probably move everything to the left-hand side. So I'm going to add the 3x squared to the left. I'd still have the minus 8x, and I'm going to move the 3 over, which is a subtract 3, and make one side less than or equal to 0. And solving a quadratic inequality, we want to find those x-intercepts, or those zeros, the solutions to this, what makes it equal to 0. And we can do that by factoring, or the quadratic formula. Could even do it by completing the square. You'll find lots of times in this unit you can factor. So, if I went about factoring this one, first of all I look, there's no common factor. So I know that I can't take out something to make my life easier. My first one is a 3x squared. There's only one option that would give me 3x squared if I multiplied that out, which would be 3x and x. My last number is a 3, which is nice because it's not a lot of options. It's like 1 and 3. But it's going to be different if you do 1 and 3 or 3 and 1. So think about the outside and the inside. We need a minus 8. Should I do 1 and 3 or 3 and 1? What's going to give me an 8 with my outside and inside? 1 and 3. So now, if I do 1 and 3, see my outside makes 9, my inside makes 1. Now that could make a minus 8 if my outside was negative 9 and my inside plus 1. Always good after you've done this to double check that everything still works. Do my first ones work? Do my last ones give me the right sign? And they do. Plus 1 times negative 3. And we already checked the outside and the inside. So now we have our solutions that at negative 1/3 and at 3, that's where it's equal to 0. Solving quadratic inequalities. Once we find out where it's equal to 0, we draw a number line and put the two numbers on the number line. And then either do open circles or closed circles. And in this situation, it's always easy to start with the open circle because you can always fill it in. Since there's an equal sign, we fill in our circles. Well, I should have been a coloring teacher. Look at that. Stayed within the lines. Maybe I'll promote that next year. See, can we teach grade 11 coloring? And see if all you would do, you come to class and just color all day, and, like, learn different shading techniques and so much. Okay, so we've got our number line. Now on our number line, we have to check where things work and where things don't work. And there's two ways we can do this. I'm going to do both ways. One, you can do test points. So you can pick a number in each of these three sections. If you pick a number less than negative 1/3, like negative 2 or negative 5, doesn't matter which point you check. Once you check one point in that section, if you don't make a mental math mistake, all the points in that section will be that way. So if you're unsure of your mental math skills, you can try 2 test points to see if they both tell you the same thing. And when doing the test points, you have options. You could plug it into the original with your test point. I personally really like using the factored part for my test point. Because if you use your factored part, you actually don't have to be super accurate. You just need to know if things are positive and negative. For example, if I choose the test point of negative 5, it's pretty obvious that if you put negative 5 in for x, this first bracket will be negative. Right? It's negative 14, but I don't even have to remember the 14. I just need to know that that's negative. If I put negative 5 into my second bracket, negative 5 minus 3 is negative 8. That is also a negative number. I don't need to know that 8 times 14 is what, 112? All I need to know is a negative number times a negative number is positive. Is a positive number less than or equal to 0? No. So we know this section is going to be false. Heck, we could plug into any section here. I think for my middle section, wherever the number 0 appears, it's like easiest mental math. You see that the number 0 happens in that middle section between negative 1/3 and 3. So I'm going to do a test with 0. And the 0 would actually be easy to test anywhere. I like it in this second one here. Can you see that you would get minus 3? Is minus 3 less than or equal to 0? True. If you plug 0 in here, this would be positive and this would be negative. Is a positive number times a negative number less than or equal to 0? Yes. Or you can plug it into the original. The original is a little bit harder, but this would be 0, and this would be positive 3. Is 0 less than or equal to 3? Yes. No matter where we check it, we find out this section is true. And finally, a number bigger than 3. And again, I use the factored one. If you tried 1,000, I hope you see that this first factor would be definitely positive. And if I put 1,000 in for x here, this would definitely be positive. And a positive number times a positive number is still positive. Is a positive number less than or equal to 0? No. This section will be false. A pattern students notice is that in parabolas, and this happens only in parabolas, it's not necessarily going to happen later on, but we tend to have things alternating. This doesn't always happen, but it happens a fair bit with parabolas. And the reason for that is method 2 is you actually look at the graph of, and here we've got it less than or equal to 0. So once you have it less than or equal to 0, you can say, well, what would this graph look like? And if I thought of that graph, because I have solved the x-intercepts, I know that this graph has an x-intercept at 3 and at negative 1/3. Does this graph open up or open down? Because the a value is a positive 3, you would know this graph opens up. And if we're looking for where 3x squared, because all of this is, if we do the graphing method, all of this is y. So now, in the graphing method, we're really looking, where are the y values less than or equal to 0? And it's really easy to see that this is your true section on your graph that way. Okay? So, I can get the false, true, false, either from the graph, but I can only use the graphing method if I make one side equal to 0, and check it. Or I can get the true, false, true with test points. Once you have the true, false, true, well, this one is false, true, false, you can write your solution, and you can write your solution either in interval notation. So in this case, we would use square brackets because those points are filled in and included, or you could write it in set notation. So your solution can be written either way. Okay, circle questions 7 and 11.